Okay, we are back, and we talked about some basics about exception in the last video. Now we are going to look at one specific topic inside exceptions, that is to raise an exception, right? Now we saw what an exception is, and I told you the next step is to figure out how to cause an exception, right? Now you might be thinking, why would I want to cause an exception myself? We will look at that right after we find out how to actually do it, right? The why question is very important. We will surely cover it, but it helps to sort of understand the basics of what to do, and then we'll talk about the why, right? Because you can get to code something, right? So that's nice. So we can cause or create an exception by raising it. That's why the raise, that name, right? The raise. An exception, as discussed earlier, is an object, right? And we can create the object and raise it anywhere in the code. Now, let me show you the mechanics of the process, right? So, the code here, this piece of code, right? So the exception I have been raised. That is how you create an exception object, right? Now, as we create this object, we tell this object the message we want to convey. Remember, every exception is supposed to tell the message of why it happened. In our case, we are just creating a dummy one, so I provide a dummy message, I have been raised. So you could say, hi, this is an error. You could do whatever the message you want to. You're just understanding mechanics, not trying to figure out how you will do in the real world. You just are trying to understand the syntax and the way you do this, right? The information of where it is happening is present implicitly in the object. Although we have ways of overriding it, I don't think we will get into that anytime soon, but without you doing that, automatically that information goes into the object. Now, remember, creating is not enough. You have to raise it, right? You have to raise the exception, this one. So that's why you create and then you raise, right? So this raising is not about throwing the exception or raising it. As soon as the exception is raised, the control moves back to the caller, right? This we saw. Now, I was telling you that there is a similarity between how function control happens and exception. So it keeps on going back like a stack, but there is a slight difference between how they work. And I mentioned that in the last video. Let me actually show it to you this time. I will define a couple of functions and show you this. I'll define a function y and a function x. X will call y, and we will see what happens. So y is defined here. Y is what x will call y, and it is raising an exception there. Now let us define x. The two functions are ready now. So if we call x, that will in turn call y, and y is raising the exception. So before, so I also put a bunch of print statements, and we'll get to that. Before running this, I want you to try and guess the output of the program, right? Let's see first. I will run it now. Pause it for a moment, think about it, and then actually run it. I'm going to run it now to show you. Okay, did you guess that? In the output, we see the exception message, right? There, exception raised. And we also see the traceback or the stack trace. right? You see it's happening in y, and that's what's mentioned here, just like we saw before. But there is something else to notice. You can see in the printed messages, you can see the before, this one. So there is a before calling y and before raising, which is this and this, right? But you can't see the after, this and this you can't see. What does this tell you? As soon as an exception happens in a function, because of some logic or calculation we did, or because we raised it, it does not matter what the cause is. In this case we are raising it, and if you other case could be that we did a 0 by 0 or something else, right? The control immediately moves out of the function. So right here the control goes back, it leaves y and goes back to x, to where the call happened, right? So that's why you don't see the after raising, right? The exception immediately bubbles up, right? And then because this exception is not handled in x also, right, the exception is again bubbling up, and that's why you don't see after calling y as well. You only see before calling y and before raising. Once it's raised, this code is not executed, this also. Because I am not doing anything about the exception here, Python will just bubble up from there too, and it will go to the REPL, the main itself, right? If you are running a normal program, it will just crash the entire program, right? So this clearly tells you that when Python encounters the exception, it will immediately pop the latest item on the stack as the latest called function and give the control back to the caller, right? To the point where it called the callee, right? So this might be confusing, but you can listen to it one more time if you want to understand, or you could just follow through this code, you will understand it. Remember this behavior, and we will see how this can be modified down the line, right? So right at the beginning of this topic, I had told you, why would I want to do this? Why would I want to raise an exception of myself? It seems ridiculous, but I can give you a very common scenario for this. So whenever you create a function which does something based on input parameters, we need to validate whether the input provided is something we can work with. If you remember, we had done something similar using the return when I explained return in the previous set of videos, right? So I could check the input, and I could instead of returning, I could actually throw an error, right? Let me show you this, it's better understood. So I will first create a divide method, and I will create it without any checks or anything like that, simple divide method. So that's our simple divide method. I'm going to call it. What do you think will happen? You know what will happen now, right? So this works, but so I got an error and it's visible and the stack trace is there, everything is there. This works, but the message is not very clear, right? From the context, divide by 0, I can't really understand. If you look at the function is supposed to be dividing, and it is not clearly telling me what is happening. Now what I can do is, I can validate the input and raise an exception which provides a better message. Let me show you that. I'm going to redefine this function. So this function I'm going to change now. In Python you can do this. You might want to do it in a normal editor. So value error is one of the many built-in exceptions in Python, and I'm using that here, and I am giving my own message. So if I find the divisor is 0, I'm just doing a simple check, and if it is 0, then I am raising an exception of my own with a relevant message, because it's divide, and if I'm saying divisor cannot be 0, then it might actually read better. Let us now actually call it and see. Same A and B. See here, so divisor cannot be 0. The new message is much more clear with respect to the function you are calling. It is clearly telling you the divisor cannot be 0. Of course, this is a trivial example. If you say create a function to calculate simple interest or compound interest, you might want to validate the input data before actually doing the calculation, and you might want to, like, you don't want negative years and all that, right? So you might do that and throw errors so that the right information goes to the caller of the function, right? And that also means they can handle it. They will, and we will see how to handle it. Exceptions are a good way of clearly telling what is wrong, because it is not an expected way of calling it. You are telling the caller, this is not what I expect as input, and that is going to cause a problem for me, and therefore I am telling you the problem. That's what an exception is telling you, right? Typical return says that everything is hunky-dory, everything is fine, but here I am saying something's wrong. I actually cannot do what you are asking me to do because you gave me the wrong input. That's what an exception conveys to the caller. So it's much more clear, right? So I was talking about the value error, right? There are a ton of built-in exceptions. I have just used one above. You can find a lot more when you go to this link, right? There is specific ones for the one I used. There are generic ones also. A lot of others are there. So when you look at this documentation, you will also find information which tells you in which scenario you should use which exception to convey the right meaning. So in this case, let us say, actually I can go to that link, maybe it might be clearer to understand then. So raised when an operation or function receives an argument that is of the right type. So we got a 0, right, which is the right type. We want numbers, but an inappropriate value. 0 is not an appropriate value for division, right? And the situation is not described by a more precise exception like index error. Index error is a different kind of exception, and this is not an index error. This is just a value error. The value is not something which I can accept for this particular function. So that's why I used value error. It fits as best as possible, right? So whenever you are going to use exception, spend some time with the documentation, right? This is specifically for value error, but you can find it for all sort of exceptions here. So so these are all the built-in exceptions. You get information about all of them here, right? So go through them. As you spend more and more time writing programs, you will also spend time figuring out these exception types so that you can choose the right one for the right scenario. And this will be very much part of your development journey, right? Next video, we will figure out how to handle an exception, right? What is the handling? You will see soon.